Hello everyone. So in this video we will be solving for the binding energy inside a deuterium nucleus. So deuterium labeled H21. So it has 1 proton, 1 neutron, and its mass number is 2. So if we are to weigh how much mass the deuterium nucleus has, so it would be equal to this variable. So mass of deuterium is equal to 2.014. Let's write it up to 0.2 atomic mass units. Now, the mass of the proton, let's write MP. It's okay, it's capital M, small letter m. Mass of the proton is 1.007825 atomic mass units. Mass of neutron is 1.008665 atomic mass units. So you would expect that if you add these two together, it should be greater than the actual mass of the deuterium nucleus, even though they have the same elements. So let's try to compute for the binding energy of deuterium. So here we have number of protons. So we only have one proton. So 1 times plus we only have one neutron, 1 times 1.008665 U, and then we subtract the actual mass of the deuterium nucleus, which is 2.014102 atomic mass units, and then multiply all the terms by c squared. So just a bit of conversion between c squared and EV. So we will, in nuclear physics, this is to ease computations. So let's express 1 atomic mass units, 1 U, into c squared. So how much does 1 U equates to c squared? So we have here E equals m c squared, and we have 1 U is about 1.66 times 10 to the minus 27 kilograms times c squared is 2.9, or let's just write it as 3 times 10 to the 8 meters per second squared. And then we convert it into joules. We convert joules into EV. So we will be multiplying this whole term by 1 EV over 1.602 times 10 to the minus 19 joules. So overall, we would get E equals 931,500 931,500,000 electron volts, or 931.5 MeV. So this value, 931.5 MeV, corresponds to the energy that is inside 1 atomic mass units. So now we want to express C squared in terms of energy, 931.5 MeV over U. So we know that 931.5 MeV is the energy, and if we divide it by 1 atomic mass units, or 1m, in this case, we would get the value of C squared. So in this equivalence, we can write C squared as 931.5 electron volts over 1 atomic mass units. So going back to our calculation earlier, here, we will replace C squared with with the value that we got here, 931.5. Sorry, this should be MeV over 1 atomic mass units. So C squared will be 931.5 over 1 atomic mass units. So here you have units of U, 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 and then over U. So in the numerator, we will be left with MeV. So if you perform this computation, you should get about 2.224 MeV. So this value corresponds to the nuclear binding energy in the deuterium.